Now, my vector addition of harmonic motion, so it can be also represented by using complex representation, complex number representation. Now, my motion, we have your x of 1 to the function of time, so this is equal to the real part. So what will be the real part here? So this is what is the real part of my a sub 1. Okay, so that is raised to imaginary angular velocity times time. Okay, and this is equal to, since the amplitude is given, no? So we have the real part that will be 10, no? We have your exponent here, exponential, we have your I, angular velocity times time. Okay. Then for my x of 2, so that will be a function of time. So we have here the real part, so that will be a2 e raised to I, angular velocity times time, and this is equal to the real part. Okay, so where my amplitude here is 15, no? And it is e raised to I, where my angle here, that will be the angular velocity times time. So this is leading by 2 regions, okay, plus 2. Now, to find the real part of the complex number, we just simply multiply the magnitude by the cosine of the angle, giving us that this will be equal to your 10, no? 10, that will be cosine of my angle, that will be angular velocity times time. Okay, and for my motion 2, so that will be 15, no? This is 15, close parenthesis. Okay, so that will be cosine, that will be angular velocity times time plus 2, and that will be plus. Okay, so this will be plus the imaginary, then we have your 5, sorry, that will be sine. So this is my sine, and this is multiplied by the angular velocity times time plus 2. Okay, close parenthesis. So that this will become my real part, and this can be expressed as my real part of this one, that will be 15, no? Cosine. So we have here the real part, taking the real part, so that will be times the angular velocity times time plus 2. Okay, or we can further express this one as your 15, no? That will be cosine of my angular velocity times time, and we have your cosine of angle, which is 2, minus your trigonometric relationship, and this will be multiplied by sine times the angular velocity times time, and that will be sine of 2. Okay, so it can be represented as that one, no? Now the sum of the term x of 1 times time, function of time, and x of 2 function of time, so it can be expressed as, we have your function can be expressed as your x of 1, no? Function, sorry, this is for my vector, that will be x, function of time, so that will be equal to the real part, okay, of my amplitude. So we have your e, so this will be your I raised to angular velocity times time, close parenthesis, plus your alpha, okay, angle alpha. Okay, so if the sum of my function 1, distance function of time, and distance 2, that is function time, so it can be expressed equal to this sum. Now to get the value of my amplitude, to get the value of amplitude, so we'll be using this here for the complex number, so we'll be using the square root. Okay, so that will be same equation previously that we've been using, that will be your a sub 1 plus your a sub 2. So this is the cosine of your theta. So this will be squared 10 plus a sub 2 sine of theta. So that will be squared. Now, where the value of my a sub 1, so my a sub 1, that will be 10, okay, and my a sub 2, so that will be 15, okay, and my theta, so it is equal to 2. So let's try to substitute that one. So this now is equal to the square root. Okay, so that will be value of a sub 1, that will be 10. So sorry, plus 15, no? Cosine the value of 2. Okay, so squared this one plus that will be a sub 2, where my a sub 2 is 15. Then sine the angle, we have your 2, so square this one. So we have the value of a is equal to 14, no? So this is also 14.147. I forgot here to convert, no? So we need to multiply this one first in order to achieve this solution answer 14 point. So we need to convert your 2 to multiply by 180 over your pi. So I can rewrite my equation here. So that will be my square root. So I'll try to expand this one. So that will be that will be 10. No. So this will be 10 plus your 15 times the cosine. No. That will be 2. That will be 2 times 180 over your pi. Okay. Close parenthesis that one. So squared. Then also on this side, so this will become your 15 times sine of 2 times sine of 2 times 180 over 5. Okay. So square this one, so squared to convert it to radian, to convert it into a degrees. Now so after substituting these values, multiplying the angle of your 2 degrees radian, so we can finally arrive on this given value. Now for the angle, okay, so this is simply as so that will be tangent of my alpha. Okay, so that is equal to a sub 2 sine of theta, so all over divided by a sub 1 plus your a sub 2, and this is times your cosine of theta. Okay, then for my a sub 1, no, so the value of my that will be a sub 2, so I have my amplitude that is 15. Okay, then this is multiplied by the sine, no, sine of theta, which is the value which is 2. Then I will multiply this by 180 over your phi to convert it into degrees, and close parenthesis on this one. Okay, then my a sub 1, the value of a sub 1, that will be 10, no? Then plus the value of a sub 2, so that will be 15. Okay, so that will be times my cosine, this is 2 times 180 over 5. Okay, close parenthesis, and close parenthesis. Okay, so my alpha angle now is equal to, so this will become your 74.59 degrees.